So hi, I'm Lily. I'm a lead engineer at Snyk, and my team is responsible for implementing features like fixing, testing, and integrating with third parties like GitHub, GitLab, and Bitbucket. And I'll tell you a bit more about what we do at the end of this talk. So I'm sure all of us here at some point received one of these emails that say important information about your account. These emails always make me very nervous about my credit card details. So the latest one I received was from MyFitnessPal. They're a food logging app, and they've gotten in touch to let me know that my account has been compromised and I should change my password. Does anyone else use MyFitnessPal? You received that email too? Great. So on the 25th of March, 150 million user accounts have been compromised. And MyFitnessPal saw a lot of scrutiny in the press for this because they have been the biggest data breach of 2018 so far. The parent company, Under Armour, saw a 4.6% drop in share prices within hours of the announcement. And that is actually similar to what we could expect for a company in this situation. According to a recent study called The Impact of Data Breaches on Reputation and Share Value, a company could see a 7% loss of customers on top of the share prices drop, as well as 31% of lost connections or relationships, because not many people want to be associated with an app that may lose all of your details. Now, I'm sure none of us here want to see their product or their website come under attack. Unfortunately, no matter how hard we try as an engineering team to write good code, no matter how many security headers we have set to try and protect ourselves from some simple attacks, even creating a bespoke CMS because it is more secure is simply not enough. Not only are we susceptible to making the kinds of mistakes that may introduce a vulnerability, we also voluntarily bring in other people's mistakes into our code bases as well with every single pull request. And we do so by introducing open source dependencies. A typical application can have hundreds or even thousands of dependencies. And by the time you've installed a couple of your favorite utilities, a framework or two, it's not unusual for the third-party code to actually be larger than your core app. I'm sure all of us here appreciate open source. We rely on it to help us get started faster. We rely on it to integrate with third parties. And let's be honest, we don't have all the time in the world to write something from scratch. And there is no guarantee that it would be any better than the current most popular app out there that has been tested for many years and has thousands of users. However, there is this idea that somehow open source is more secure. There's even a law that emphasizes this, and it states, given enough eyeballs, all bugs are shallow. However, if you have not put effort into securing your code, that code is simply not secure. In the recent Snyk survey, there has been a large increase in published packages, open source packages in particular. NPM saw almost 60% increase. However, the vulnerabilities reported have also been on the increase since 2016 by 43% and 39% more in 2017. Only 16.8% of maintainers within that survey said that their security knowledge was good. And almost 44% have actually never conducted a security audit on their code. And yet these are the packages and maintainers that we trust every single day, and we put that code onto our production servers. In most recent attacks, the attackers have exploited known vulnerabilities in open source packages. I wanted to run through just one vulnerability just to give you an idea of what kind of mistakes maintainers make every single day that you might not even notice. Does anyone here use Marked? One person, yay. Was one person last time too. Okay, so Marked basically allows you to use Markdown. There's been a vulnerability in Marked version 0.317 and below, and it is called resource exhaustion, which means that the attacker could execute a regular expression denial of service attack, which is a mouthful. So denial of service is an attack which brings down your site by making it inaccessible. But regular expression denial of service is an attack that specifically targets regular expressions in your code base in order to make your website unresponsive. So there's something called catastrophic backtracking, and in the Marked library, inline tags and the no linked were affected by this. So we'll run through what catastrophic backtracking is. So with regular expressions, they're very powerful, but they're really easy to get wrong. And testing an invalid string can actually be much, much, much longer than testing a valid string. So with catastrophic backtracking, the match happens by matching a character, first character. We could proceed to the second character, but if the second match has failed, what we would actually do is we would go back or backtrack and try and match again via a different way from character number 1. So if we have a look at an example of a very simple regular expression. So in this regular expression, we're expecting a string that would start with an A, followed by B or C any number of times. That could be repeated, followed by a D. So after we've matched the A, the middle bit could have many different paths to a match. And in this example, if we're matching a string A, C, 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 X, the C's could be seen as either 3 C's or 2 C's followed by a C, or a C followed by a C followed by a C, and so on. So that means the more characters we have that have a valid regex path, the more we increase the backtracking steps, and this is exponentially increasing. This can become extremely slow. So this is a regular expression that was actually vulnerable in a different package, and I wanted to do a little test and see how would this perform if I used a string that an attacker would use. So this string is actually not long enough to take down a site, but it did almost kill my laptop. So it was 34,000 characters, and it took almost 29,000 steps to match that string, only to realize in the end that it was not a valid match. I wanted to try more, but like I said, I had to stop. It was getting ridiculous. This took 37 milliseconds. So in the marked library, this is the pull request diff. So as you can see, that regular expression is really long, really massive, and let's be honest, if any of us were reviewing this, probably wouldn't have realized anything was wrong with it whatsoever. So the string that was the string to take the site down is the one below, where you have loads of matches, but in the end, it was never going to match. And that was capable of taking down an entire website just because you had a library allowing users to write Markdown as input. To remediate, if you're using this, upgrade to the latest version. So the real question is your app vulnerable? Who here thinks their app is vulnerable? Yes. The answer is yes. So those that didn't put your hand up, it's definitely vulnerable. And your app is vulnerable if you don't know the answers to at least these 3 questions. I had to cut them short because it's a lightning talk, but do you know the versions of all the packages that you use and their dependencies? Anyone? Nope. Are you using any dependencies that are no longer maintained? Do you in fact know if they're maintained or not? Anyone? Nope. Do you scan for vulnerabilities or subscribe to security updates? Also no. Do you remove any default configuration or unwanted features? A lot of the recent breaches have actually been due to us not removing default configuration. It's there to get you started and it's there to help development go smoothly, but you're meant to take it completely down or off as soon as you deploy, and it's really easy to leave in. So how to improve your security today? I'll just give you a few tips and I'll show you what Snyk can do for you. So first of all, it's very important that our organization has a plan for monitoring, triaging, and applying updates. Also, there is this popular phrase in security which says shift security to the left, and that means that you don't need a security team to start investing in security, and it should come from developers and everybody else in the team as well. But also, it's very important to start making it part of your everyday process. Security can be quite manual, but there are different ways that you can automate as many steps as possible. Automating as much as possible. There you go. So, Snyk. Snyk is one of the tools that can help you automate security. I'm sure you've all seen NPM or the GitHub security alerts. So they are a very small step forward. I would start listening to them, but they mean that you would have to go and manually act on it or do something. So there are better ways to do this. You can obviously automate a lot of things all the way, including fixing. So with a tool like Snyk, there are others, but with a tool like Snyk, You could get a portfolio of all of your packages that you are using and also automatically monitor for vulnerabilities within your open source packages. So not only are you bringing in a package that you think you are, but that package might have 300 dependencies and you might not even know what those dependencies are without looking at the source code. Email and Slack alerts, always useful for new vulnerabilities, automatically upgrading and applying patches. Pre-commit hooks. So if possible at all, set up pre-commit hooks and fail if you've introduced a vulnerable package before you even push, or do so on PRs. Obviously licenses. I don't know if anybody here is concerned about using licenses that would violate their usage, but that is a common use case for larger companies to make sure that you're not violating any of the licenses. So with Snyk, you could import your project and then start monitoring from there, which would send you emails and alerts. And the best thing is, of course, automatic fix PRs. So for things like JavaScript, it's possible to calculate remediation advice, which would mean that it would upgrade it to the least possible package that would bring in a non-vulnerable version of the package that might be vulnerable. And the PR checks as well. And that's it. Thank you.